12 MHF4U Unit 9 Test Review Seminar. So we're going to go over different concepts from the Unit 9 guide. First of all, the factors theorem, because a key concept with long division, synthetic division, is the factor theorem and the remainder theorem. So first of all, to find a factor, we always want a remainder of 0. If the divisor does not go into the quotient with a remainder of 0, then it is not a factor. So when a polynomial f of x is divided by x minus a and f of a is equal to 0, that means x minus a is the divisor. So this is a example of a test question you might get using the concept of factor theorem. This is going to count as your Unit 9 notes, but 12x cubed plus kx squared minus x minus 6 has 2x minus 1 as a factor. So that means we're assuming there is no remainder of 0. Find the value of k. So to translate this, if 2x minus 1 is a factor, then when you plug into the function, f of 1/2 has to be equal to 0. Now the way I got 1/2 in the first place is to solve for the value of x. 2x minus 1 is equal to 0. 2x is equal to 1. That means x is equal to 1/2. So that has to be our input value. So if I take the original equation that I've been given, 12x cubed minus kx squared minus x minus 6 is equal to 0. Now obviously I am trying to solve for k, but wherever you see x in the equation, so my x cubed, my x squared, my negative x, I'm going to plug in the value x is equal to 1/2 into that equation. So this becomes 12 times 1/2 cubed minus k times 1/2 squared minus 1/2 minus 6 is equal to 0. That gives me 3 over 2 plus 1 over 4k minus 1/2 minus 6 is equal to 0. So 1 over 4k is equal to 5. If I divide both sides by 1/4, I'm going to get a final answer. K is equal to 20. So I can rewrite my original polynomial equation now as positive 12x cubed plus 20, that's my k value, x squared minus x minus 6. That's my original polynomial equation of solving k using the concept of the factor theorem. Okay, so that makes sense? Okay. Kind of taking that k, we had to solve for k terms before in the MCR course when we were dealing with quadratic equations. So it's very similar to that. Okay, now I need to talk about the remainder theorem. So the remainder theorem is when a polynomial f of x is divided by x minus a, and the remainder is f of a. So that means your dividend is going to be equal to your divisor times your quotient plus your remainder. F of x is your divider translates to your x minus a multiplied by your quotient. where f of a represents your remainder. Okay, so let's extend this page. So we're going to do an example of long division with polynomials. So let's say you have a question, x plus 7 is your divisor, and I want to know how many times it goes into x cubed plus 7x squared plus 2x minus 5. Okay, first of all, according to the remainder and factor theorem, if x plus 7 has a remainder of 0, then it's actually a factor, which means it's a root. It's also one of the x-intercepts of my function, right? But when I divide x plus 7 into my quotient, if I do have a remainder, then it's not going to be a factor, and it's not going to be a root. So to find a factor, we always want a remainder of 0. Now, instead of going through the whole process, and also because this is a long process, I kind of want to use the remainder theorem to figure out what the remainder is first of all, so I know that I've got the right answer at the end. So what I'm going to do is, if x plus 7, if we set that equal to 0, then x minus a would actually be x, give me a value of x is equal to negative 7. So what I'm trying to do is going to be to find f of negative 7. So into this function, into my quotient, I'm going to plug in negative 7. So instead of x cubed, this is going to be negative 7 cubed plus 7 times negative 7 squared plus 2 times negative 7 minus 5. So I'm plugging in negative 7 as my x value. When you actually punch that out, you're going to get negative 19. So right away I know that x minus 7 is not a factor, it's not a root, okay, of the equation. But that is still what I've been asked to find. So I'm going to do my long division, and I'm going to try to get my, make sure that my remainder has to be negative 19 to make sure that you have the right answer. So when you're doing your synthetic division or your long division, first focus on the first two terms. So I know that x plus 7, and really primarily you're going to look at the leading coefficient, the leading term. So you want to figure out how many times can x go into x cubed, right? So I know x times x squared is going to give me x cubed. So I'm going to multiply x plus 7 times x squared. Because this is a binomial, it's going to generate two terms. So I get x cubed plus 7x squared, which works out perfectly. When we subtract, we get 0. So usually, if I actually got a term there or a number, I would only bring down the 2x. But because I have a 0, and my binomial multiplied by anything is going to give me two terms, I'm going to bring down two terms, the 2x and the negative 5. And once again, I'm going to look at my leading term, my x, in my divisor, and I know that x is going to go into 2x positive 2 times. So, positive 2. And x plus 7 times positive 2 is 2x plus 14. Now watch what happens, because we always subtract, just like you did division in elementary school, you would subtract. 2x minus 2x is 0, but negative 5 minus 14 is going to give me negative 19, right? So my remainder is negative 19, which, when we go up, is exactly what I predicted my remainder was going to be according to the remainder theorem. So now I can rewrite my final question in terms of this formula. F of x is going to be equal to my divisor multiplied, so I'm going to use the formula to write down my final answer. move down. So we're going to shuffle it around a little bit. So I have proven using long division that x cubed plus 7x squared plus 2x minus 5 is equal to x plus 7, my divisor, multiplied by x squared plus 2, and remainder 19, minus 19. This shows, by the remainder theorem, when a polynomial f of x is divided by x minus a, the remainder is f of a. Negative 19 represents my f of a. Does that make sense? Okay. Okay. Next question. So, in a polynomial division question, the divisor is x plus 2, the quotient is 2x squared minus 1, and the remainder is 1. Determine the dividend. So this is kind of an application of what we've just learned. So I'm going to write down the formula first. We know that the dividend is equal to the divisor times the quotient plus the remainder. So this is going to be equal to, I know my divisor is x plus 2. I know my quotient is 2x squared minus 1. And I know my remainder is positive 1. So the first thing I have to do is use FOIL on my two binomials and then add my remainder. So you'll get a final answer of 2x cubed plus 4x squared minus x minus 1. Make sense? Okay, next test review question. Determine a polynomial equation, a possible equation of the degree 6 for the function shown in the graph below. Okay, so this has a number of different possibilities, but because it says possible equation, it didn't say determine the exact equation, it said determine the possible equation. So when you have a question like this, the first thing you're going to do is pinpoint the roots. So I know I have a root at negative 3, at positive 1, and at positive 3. So negative 3, positive 1, positive 3. So f of x. Let me write those in. Negative 3 can be represented as x plus 3. Negative 1 would be x minus 1. And positive 3, x minus 3. Now we can have an a term. We don't have to have an a term. Because the graph, though, is facing downwards, it's facing concave down primarily. So I think my a term can be in any type of negative number. I'm going to put a negative 2 there. And because the degree has to be 6, I have to find a combination so the powers are going to add up to 6. Now you'll notice that negative 3, it kind of looks like a cubic function. Kind of looks like a backward cubic function. So I'm going to say x plus 3 to the power of 3. That means I have 3 more powers to play with. So at positive 1, it kind of looks like a quadratic equation. So I'm going to have to the power of 2 and leave x minus 3 to the power of 1. So if we add up all those exponents, 3 plus 2 plus 1, you get a degree of 6. That's how I would answer this question. Okay, the last question involves some more division as well as a table. Oops. But we're going to do the opposite. So what if I gave you the equation f of x is equal to x minus 3 times x plus 1 squared x minus 5. And I told you you had to sketch this graph. Okay? You have to tell me what the graph is going to look like. Okay? So this, I made a mistake. We're not using any synthetic division. Say I gave you a quadratic equation and then we used synthetic division to find all the roots, and now you have the simplified form of the equation. Okay? Now you need the simplified, you need to know what the roots are in order to graph it. So to sketch this a little bit, I know there is going to be a root at -1, +3, and +5. But I have to figure out the behavior of the graph. So from -1 onwards, this way, what is the behavior of the graph going to be? Between -1 and 3, what is the behavior of the graph going to be? Between 3 and 5, what is the behavior of the graph going to be? So 1, 2, 3, and then beyond x is equal to 5, what is the behavior of the graph going to be? So my graph is going to be divided in 5 sections. And we can translate what I just said mathematically into a table. I'm going to put my roots on the left-hand side. So x minus 3, x plus 1, x minus 5. Those are my roots. I'm going to draw a line here. And the behavior of the graph f of x, I'm going to place over here. Okay. That's a good start. Now at the very top, I'm going to illustrate those regions that I talked about before, the different parts of the graph that I need to analyze. So I need to figure out how the graph is going to look like when x is less than -1. I need to know what the graph is going to look like in between -1 and +3. I need to know what the graph is going to look like in between +3 and +5. And I need to know what the graph is going to look like when x is greater than 5. Does that make sense? So I'm going to write down my roots. -1, then +3, and +5. Okay. So the next part is very simple. Now there's a reason I didn't write x is equal to +3, x is equal to -1, x is equal to +5. There's a reason why I didn't do that. Because, and remember, also write the exponents attached to it. This is a squared, and this is x minus 5. Okay, so I'm going to pick any number in between, that is less than -1. So let's say -4, for example, okay? And now I'm going to plug that in as my x values. Is -4 minus -3, is that going to give me a negative number? Yes. -4 plus 1 is going to be -3, but -3 squared gives me a positive number, right? So that means that's positive. And -4 what was I using? -4? -4 minus 5 is going to give me a negative number. Oops. Negative number. Now, when I focus in on these signs, a negative times a positive times a negative. My end result is negative and a negative make a positive, multiplied by another positive. the graph is going to be positive when x is greater than 1, or concave up. So it's going to look something like this when x is greater than -1. I'm going to do that in each section. So between -1 and +3, I can use the value +1. Well, +1 minus 3 is going to give me a negative number, negative sign. +1 plus 1 squared is going to give me a positive. And +1 minus 5 is going to give me a negative. Well, same thing. My graph is going to be positive in between -1 and 3. That means it's going to remain positive between -1 and 3, like this. Okay, so it's not going to go underneath concave up. It's going to stay positive in the positive region. Same thing again, in between 3 and 5, the number 4. 4 minus 3 gives me a positive number. 4 plus 1 squared is going to give me a positive number. But 4 minus 5 is going to give me a negative number. And no matter what, positive times a negative gives me a negative. So my graph is going to be in the negative region between 3 and 5. So my final option, my final region is when x is greater than 5. So either the graph is going to go down like this, or the graph is going to continue to go up, or be in the positive region. So, again, if you pick any number greater than 5, so +6, and you plug it in, you're always going to get a positive sign. So my graph is going to remain positive. And I've just used my factors and a table and my intervals, which you learned when you were doing inequalities in between, less than, greater than. You put all these concepts that you learned in your MCR course together to sketch a function based on a very complicated equation. But this isn't complicated at all, right? Get it?
How do you know which numbers to use?
So that's a very good question. You're using any number in that interval. So any number that's less than -1. If I use anything in between -1 and 3, so I could use 0, I could use 1, I can use 2, I could even use 1.4. It's any number in that interval, okay? Any number in the interval 3 and 5, which is really 4, but I could use 4.2, I could use 3.8, right? Any number and it'll work. Make sense? Okay. I believe that is it for our test review, unless I've done anything, added anything else. No.